In this video here, we're going to be talking about the end behavior of polynomial functions, right? So what end behavior refers to is when you graph a polynomial function, what happens on either end, right? Polynomials always go, in both directions forever. So they go off towards x equals infinity, and they go off to the left towards x equals negative infinity. Right? When we're talking about end behavior, what we're really asking is, well, as you go off to the right, off towards infinity, does the graph go up or does it go down? Right? Does y go towards infinity or does y go down towards negative infinity? And same idea on the left. As the graph moves way off to the left, as x approaches negative infinity, does the graph go up as y approaches infinity, or does the graph go down and y approaches negative infinity? Right? So that's what we mean by the end behavior of a polynomial function. And every polynomial function has one of those types of end behaviors, right? So there's a couple pretty basic rules that you can tell just by looking at the leading term of a polynomial. If you don't know what that means, you should look at the video that I did about the definition of a polynomial and some of the terminology that we use. But the leading term is the number times the x raised to the highest exponent that you have in your polynomial. Right? So the highest exponent, that gives you your degree of your polynomial, and that also gives you your leading term. So if we look at whether the degree is an even or an odd number, and then we look at the leading coefficient being either a positive number or a negative number, that's going to completely determine the end behavior of the graph. As far as like when you go off to the end, are they going up? Is one going up and the other going down? All that is determined just by that leading term. Okay, so I put this up here kind of like a little table so you can kind of hopefully see some of the patterns and some of the similarities that we have here. Right, so first off, if we have an odd degree polynomial, right, so odd degree, again, that means that the highest exponent that we have is an odd number. So an x to the first power, x to the third, x to the fifth. Those would be odd degree polynomials when those numbers that I mentioned are the highest degrees that you have. Right, you could have x raised to, you could have like x to the fifth plus x to the fourth, where 5 is an odd number and 4 is an even number, but it's still odd degree because the highest exponent is a 5, and 5 is an odd number. Right? So if we have an odd degree polynomial, our end behavior is that both ends go in opposite directions. One end goes up, the other end goes down, or the other way around. Right? So notice for the odd degree, both ends are going in opposite directions. When we have an even degree polynomial, right, so that's going to be when our highest exponent is an even number. So an x to the second, x to the fourth, x to the sixth, as the highest exponent that we have. Well, when we have an even degree, both ends go in the same direction. Either both ends go up or both ends go down. Right? So that's the first thing to be aware of. Even degree, both ends go the same. Odd degree, both ends go in opposite directions. And you can think back, and hopefully you're already familiar with the graphs of linear functions and quadratic functions. Right? Linear functions, the graph is just a straight line. Right? It either has a positive slope or a negative slope. Right? Quadratic functions are parabolas, which either open upward or they open downward. Well, think about it. A quadratic function is an x to the second power, which is an even degree. Right? So for a parabola, it either both ends go up, like here, or both ends go down, like we have over here. Right? So any even degree polynomial follows the same end behavior of just the basic even degree, which is the quadratic x to the second power. Either both ends up or both ends down. Right? Every even degree polynomial follows that same end behavior. And notice on the graphs that I have here, there's like little dotted lines. Depending on what the degree actually is, like if it's an x to the second power, it's just going to be a parabola, and this is going to be one thing here. Where if I have higher degrees, I might have more curves in the middle, but the end behavior is going to be the same no matter what the degree is, as long as it's an even degree. The end behavior is going to be one of these two things, no matter what happens in the middle there. Right? So the even degree follows the same pattern as a quadratic function. Right? The parabola, either both ends are up or both ends are down. The odd degree polynomials follow the same pattern as a linear function. Right? For a linear function, if it has a positive slope, well, the left side is going down and the right side is going up, just like this here. Right? Or if the linear function has a negative slope, well then the left side is up and the right side is down, just like this one over here. Right? So every odd degree polynomial follows that same behavior as just a linear function. Right? A linear function is an x to the first power, and 1 is an odd number. Right? So if you remember the basics for linear functions, it's either going this way or that way. For quadratic functions, it's either this way or that way. Then you basically already know this. Right? It's like I say in a lot of the videos that I do, try not to just memorize a whole bunch of new stuff. If you see how it connects to things that you already know, then it's not just a bunch of brand new things. It's just an extension of stuff that you already understand, right? Which makes it easier to remember this stuff if you see it as an extension of things you already know, as opposed to something completely new. That's harder to get when you think of it as something new, right? So even degrees behave like parabolas, like quadratic functions, x squareds. Odd degrees behave like linear functions, like x to the first power, like straight lines, right? And again, the higher the degree is, the more ups and downs you might have in the middle. But that end behavior, remember, the end behavior only refers to way off on the right side and way off on the left side. All right, so now we hopefully understand odd and even degrees. Even degrees are the same direction, odd degrees in opposite directions. Now, how do we know which one it's going to be? Right? How do we know for an odd degree whether the right side is up and the left side is down, or if it's the other way around? That's determined by the sign of the leading coefficient. Right? Remember, the leading coefficient is the number that's attached to that x raised to the highest power. If that leading coefficient is a positive number, then the right side is going up and the left side is going down for an odd degree. Right? Just like for a linear function, the leading coefficient is the slope. Right? Think of a linear function, y equals 5x plus 2. The slope is 5. That's the number that's attached to the x to the highest power. It has a positive slope. The left side is down and the right side is up. Right? What if my linear function had a negative slope? Well, then it has a negative leading coefficient. Right? So if it was y equals negative 2x plus 3. Right? Well, if it has a slope of negative 2, it's sloping downward. The left side is up and the right side is down. Right? So again, odd degree polynomials follow the exact same end behavior as a linear function, with a positive leading coefficient and a negative leading coefficient. It's like a linear function with a positive slope and a negative slope. The end behavior is the same. It's just that if I have a higher degree, if I have an x to the third or an x to the fifth power, I'm probably going to have some ups and downs in the middle here. It's not just going to be a straight line, but that end behavior follows the behavior of a straight line. Right? Positive slope, left is down, right is up. Negative slope, left is up, right is down. Right, so hopefully that makes sense. Again, relating it back to something that you already know, right? Every odd degree polynomial follows the same end behavior as just a basic linear function. Positive slope, negative slope. Right? Even degree polynomials, same deal. They follow the same end behavior as a quadratic function, a parabola. Right? Both sides up or both sides down. Well, hopefully you watched the video that I did on quadratic functions, and if you did, you would know that leading coefficient, that number that's in front of the x squared, if that's positive, the graph opens upward, both ends go up, just like here. And if that leading coefficient is negative, if it's a negative x squared, well then that flips the graph over. And this also relates to the transformations of graph. The negative in front is the reflection, it flips it over. So then both ends go down, right? If I have a negative x squared, it's a parabola facing downward, where both of my ends go down. Well, for any even degree polynomial with a negative leading coefficient, both ends go down, just like a negative quadratic equation does. Right? So if you remember the basic shapes of the graphs for a linear function and for a quadratic function, and when you have a positive or negative leading coefficient for those, then you already know these rules. Right? Every odd degree has that same end behavior as a linear function. Every even degree has that same end behavior as a quadratic function. Right, so hopefully that makes sense to you, so this stuff is not so mysterious. Because if you don't understand all that stuff I just talked about with the linear and the quadratic function, and you look at all this, you're like, wow, that's like a whole bunch of stuff I have to memorize. But if you know that stuff about linears and quadratics, you don't have to memorize a whole bunch of new stuff. You just have to extend your understanding of what a linear function looks like and extend it to other higher odd degrees, and take that information you know about quadratics and extend it to other higher even degrees. All right. Now, one other thing about this that I haven't mentioned yet, but it's all over the places up here, is the notation that we use for end behavior. Like if you see a problem that says, describe the end behavior of the graph of this polynomial, generally you don't give your answer to just drawing arrows like we have up here. Right? You give your answer like what we have here. X approaches infinity, y approaches infinity, x approaches negative infinity, y approaches negative infinity. Right? So every time you're describing the end behavior of a polynomial, there's always going to be two parts to it. There's going to be one part where x approaches negative infinity. That means you're moving to the left side. And the other part is going to be as x approaches positive infinity, which is when you're moving to the right side. Right? So if you look at all four of the squares up here, each one of them has one thing where x approaches infinity, the other one where x approaches negative infinity, right? X approaches negative, x approaches positive infinity. X approaching negative infinity, x approaching positive infinity, x approaching negative, x approaching positive infinity, right? And that little arrow there means approaching, right? So this is x approaching negative infinity, right? So every time you write the end behavior, it's going to have one part where x approaches negative infinity, one part where x approaches positive infinity. One for the left, one for the right. Now each of those is also matched up with a y, right? And the y just refers to, well, is the graph going up or down, right? X is the left and right direction when you're looking at the graph. The y is the up and down direction, right? So as you're moving off to the right, if the graph is going up, then y is approaching positive infinity. If your graph is going down, then you put y approaches negative infinity, right? It's as simple as that. I know a lot of these, sometimes people look at this like, oh, there's so many infinities and x's and y's and arrows. It's like so many different things I have to memorize. Don't think about it as trying to memorize. Just think about, again, understanding which direction it's going to go based on being positive or negative, even or odd, again, based on linear and quadratic functions. And then it's just, well, left is x approaches negative infinity, up is y approaches positive infinity, right? Right is x approaches positive infinity, down is y approaches negative infinity, right? So again, the x's are left and right, positive infinity, negative infinity. The y's are up or down. Positive infinity is up, negative infinity means it's going down. All right, so those are the notations that we use to talk about end behavior. I'm going to pause the recording here and put up a couple examples of polynomials, and we'll talk about what the end behavior of those graphs is going to look like. All right, a couple examples up here of polynomial functions, and we are going to describe the end behaviors of each of these graphs of these polynomials. So the first one, p of x equals negative 2x to the fourth plus 5x to the third plus 4x minus 7. When I'm looking to describe the end behavior, the only thing I care about is the leading term, which, remember, the leading term is the term that contains the x raised to the highest power, which in this case is the first one, that negative 2x to the fourth power. All that other stuff doesn't matter in terms of the end behavior. All that other stuff determines like how the graph curves and like where it hits high points and low points, but it doesn't do anything to affect the end behavior of the graph. Just that leading term tells us the end behavior. All right, and what I look at in the leading term is the leading coefficient, which is a negative 2. That number being positive or negative. So I have here a negative, and then I have then I also look at the degree of the polynomial, which is the exponent that I have there. Is that an even or an odd number? Right, so I have a negative, even. Right, 4 is an even number. The even, remember, doesn't refer to that leading coefficient. The leading coefficient, it gives you the positive or negative. The exponent gives you the even or odd, right? So that's what you're looking at. So I have a negative leading coefficient with an even exponent. So remember, even exponent, that's like an x squared, right? That's like a parabola. So either both ends are going up or both ends are going down. And since it's a negative leading coefficient, right? Remember, negative is what flips over the parabola. So both ends are going to go down here, right? So this is generally what the graph is going to look like. Now there's going to be some ups and downs in the middle, but this is what my end behavior is. Both sides will be going downwards. All right, so okay. Even exponent tells me both ends go in the same direction. Negative tells me it's flipping over and going downward. All right, so now to write this in the proper notation, all right, so I have two parts. I have x approaches negative infinity, and I have x approaches positive infinity. Right? Negative infinity means we're moving to the left. X approaches positive infinity means we move to the right. And then I describe what happens to y as I go to each side, right? So if y is going up, then y approaches positive infinity. Down would be negative infinity. Well, here both sides are going down, so on both sides, y is approaching negative infinity. So that's my end behavior for the graph of this function. As x approaches negative infinity, moving to the left, y approaches negative infinity, going down. As x approaches positive infinity to the right, y approaches negative infinity, going down. All right, next one here, p of x equals 3x to the fifth minus 5x to the third plus 2x. Leading term, 3x to the fifth. Positive leading coefficient, and an odd degree, right? 5 is an odd number, right? So positive odd, well, odd degree is like a linear function, and a positive slope is going up like this. So the left side is down, the right side is up. So as x approaches negative infinity, as x approaches positive infinity, negative infinity, on the left side, y is going down, so y approaches negative infinity. On the right side, y is approaching positive infinity, because on the right, the graph is going up, there's our end behavior.